Well, okay, I think we can start. Okay. So whatever we have covered in BEAM, it is clear, right? You are not getting confused, right? What about Abdullah? Abdullah, you have any comments? Because this is covering an exam. That's why I'm intrigued that everyone is understanding. Huh? Okay. Now, this fellow is hollow. So this is D2. Okay, let me ask the question. This is your A. This is B. Let's do A together very quickly. The question says a vertical post 2.5. Okay, we have 2 minutes. I think we need to wait. I can just put the part A of the question as what is the minimum required diameter D1? Minimum D1 of the wood post. We are talking about part A. Forget about part B. If the allowable bending stress in the wood is 15 megapascals, boom. So Ebu is joining us today online. Hello, Ebu. Hello, Ebu. How are you? Good. Ebu is doing good. Okay. Six, 5, 4, 3, 2, 1. Okay. Do this question. Number one. You are with me, right? How would you approach this question? Number one, somebody forget about part B. For part B, I haven't even shown you the loading. Focus on part A. Again, the same question over and over again. In the part A, it's a solid wooden circular fellow. You can imagine it like as signboard, right? When you even walk here to our academic block, you have these signboards. You have a circular fellow and there is a signboard. So imagine like this, that whenever there is a wind gust, then even this solid fellow has the tendency to bend. Huh? So even these little things are taken into account in designing. So the load is applied right at the corner. You have to give me the minimum diameter D1. Again, focus on part A. If the allowable stress is 15 megapascals. What is your approach? Number one, quickly follow me. This is a bending problem, right? So I will have stress equal to, I will write all the formulas minus mzy over iz. And right at the end of the class, I also wrote stress x equal to m, I forgot, y, I, my, what am I doing? Z over I, y, I think. And why shouldn't I write it like this? There are students who are getting confused, so I will write it like this. Stress is equal to M C over I. How many students agree? Can you all focus here? What did I do? I just wrote it MC over I. What is C? Now, C, no, this is what I'm about to tell you. C has always been denoted as radius. From here onwards, I will denote C as the maximum distance from the neutral fiber. So even if I had a rectangular section, I would have still used MC over I, with C being the maximum distance from the neutral fiber. Everyone is clear on this? Now, all of you are wondering, why did I remove the minus sign from the green formula? Well, I removed everything from the green formula. I did not put a Z, I did not put an X, I did not put a Y. I let you play with the imagination. So for example, in this part A, when you are pulling it like this, it's crystal clear what will happen. This portion will stretch and this portion will compress. Everyone knows this, right? So negative, positive, like what negative, positive? I'm crystal clear what will happen. So instead of using the stress X equal to minus MCY over IZ, you surely can. You also can do MC over I, but you need to have an idea how the fibers are behaving. So students who still want me to use this, I surely can. Okay, so what is the allowable? 15 into 10 power 6 pascals equal to. There is one portion which I will let you handle. Okay, what is the moment? Again, use statics. What will be, this is a cantilever support. So 12 multiplied by 2.5 will be the reaction here. And when I cut from any place, that 12 multiplied by 2.5 will show up. So it is 12. Please understand that I am skipping the statics part. So if anyone has any qualms, you stop me there. Huh? Statics, I'm not going over, but if you are confused, you let me know. Huh? 12 multiplied by 1000 multiplied by 2.5. Multiply by, what is the C? So in this problem, it's a solid fellow. It is unknown. D1 by, good. D1 by 2.
Is the neutral axis lying straight in the center?
No, not if. The neutral fiber will pass through the centroid. So you said if, I will remove that if. In this part A, for sure, the neutral fiber is, because neutral axis goes through the centroid. This is solid. Okay, then divided by I. What is the value of I?
Value of I, P is 2 times C4.
No, this is why I asked, because I knew everyone will actually tell me this formula. You have to be crystal clear. Look. Okay, I don't want to play with this one, but I will. Look, for torsion problem, I used to twist like this. Our online students can hear me, right? Dogu Khan and Abu, can you confirm?
Yes, Hujam, we can hear you.
Okay, look, for the torsion problem, I used to do like this. Hang on. Shear stress equal to TR over IP, right? Remember that? TR over IP. So I used to do like this, like this. So this circular section used to resist. That's why a polar moment of inertia, IP, used to come in the denominator. Agreed? This time you are not doing like this. No, you are just doing like this. So you have I that appears, not IP. So Google, smartphone, Google it. Google moment of inertia of a circle. Then Google polar moment of inertia of a circle. I already know it, by the way. I want you to do moment of inertia of a circular section. Then do polar moment of inertia of a circular section. Do them separately. I already know the answer, so I will write it down. So Google will tell you that IXX, let's say, moment of inertia of a circle is pi d power 4 over 64. Then this is I. Students are confused, right? Then what about IP? Google will tell you it is pi d power 4 over 32, which many of you told me that it is pi by 2 c power 4, and I agree with you. Okay. Are you following me? Which one is larger? This one is larger or this one?
Below one is
Larger. How much? 2 times. So actually this fellow plus this fellow again. So Ixx plus Iyy will be moment of inertia about this, moment of inertia about this axis plus moment of inertia about this axis. They add together and give me the polar moment of inertia. Anyways, these are the little things that you have to imagine and think about. Okay. So I will write here pi.
So if it were symmetrical, it would be not the half, right?
Very good. If it had been like, very good. So if it had been like this, his question is, if you want to find polar moment of inertia, then polar moment of then moment of inertia about this axis plus this axis will give you the polar. I'm pretty sure, but yes, I will add them together. But for this structure, about this axis and this axis, it's not the same. But for a circle, are you following me? Look, you bend it like this, or you bend it like this. Either way, it's a circle that is bending, right? So its I value is pi d power 4 by 64. Sorry. If you don't want me to write like this, do you want me to write in the form of radius? Because you guys are comfortable in radius. Okay, I will do it again. Pi by 2 c power 4 divided by 2. Fine. But the problem is this is in the form of d1. So that's why I don't want to do it like that. Pi by 64 d1 power 4. Okay, give me the d1. you are following me, right? Everyone. What I'm saying is that the TR over J or TR over IP, that was the polar moment of inertia. This one is not polar. The ability of object to resist, hang on, everyone. The ability of object to resist this, or the ability of the object to resist this, for sure they are different. For sure they are different.
Also, length is not affecting the moment of inertia with respect to X and Y, right? Like because
no, length has moment of inertia of the area moment of inertia of a section has nothing to do with how long it is. The length of it comes into picture because of the fact that there is a moment. But this is big, this is small. When I'm talking about how the section resists the rotation or the bending, separate cases, then it's moment of inertia or polar moment of inertia.
So, for example, if rho turns like this in case.
So, first of all, we are talking.
Inertia will be same like pi over 64 times the power 4.
Say that again. What are the two cases? If it bends like this or it bends like that?
No, like I'm asking generally, not strength of materials.
Okay.
If the rod turns like this, like there's a moment of inertia, right? When this object turns like this.
This is no. Hang on. I understand your thing. I will take the second part as well. What you're talking about is dynamics now. This is different. This moment of inertia that you're talking about, that is the moment of inertia of a rod. So it is rotating like this, or it is rotating about its corner. Both of them will have different moment of inertia. I am talking about the area moment of inertia. These are different. What you are talking about, we will talk about in dynamics. What we are talking about is strength of materials. This is more like an area moment of inertia. What you're talking about is the moment of inertia that we use in dynamics. So the rod is rotating like this, about its center, or the rod rotates about here, both of them will have different moment of inertia. Give me the D1, everyone. 1 minute, 1 minute. 0.273?
No. 273.
Yes, 273 millimeter.
273.
Done? Okay. Okay, hang on. Is this clear to all the class, or is there anyone who wants me to make X's and explain by this formula? I have used the green one, huh? Do you want me to use this formula?
Sir, I have one question. When are we going to use that formula BH cube over 12 for the moment of inertia?
When you have a rectangular section, the rectangular section has a moment of inertia, area moment of inertia, BH cube by 12. Okay. If I bend it like this, this will be B, this will be H, you know the trick. Okay. If I have, if I bend it like this, then okay, we did all those cases in the last class, but BH cube by 12 goes for rectangle. This one is circle. Okay. Okay. Is there any student who wants me to now make X's and do it? Okay, I can do it for you. This is your X-axis, always along the fiber. Then Y will be this one. Okay. And or probably hang on for a second. Probably like this. Sorry. Let's say this is Y. Sorry. Probably like this. I think he's right. This is.
Can we select this arbitrary or?
1 minute. Yeah, you can probably. 1 minute. So it will be like this one. Anyways, there was no need to make this problem so complicated, but I just did it. So along the fiber, I have an X like this. So now you can put it in this formula yourself and play with it. Okay. Okay. So everyone will do it, right? Okay. Now do the part B. The part B says that if you have part B says, oh, come on. Part B says, what is the minimum required outer diameter D2 of the aluminum tube if its wall thickness, part B, if its wall thickness, because it's your exam next week, that's why you have observed that I'm going a little slow. Otherwise, by this time, I would have started the next topic. If the wall thickness is to be 1/8 of the outer diameter, and because there are not many assignments on this one, so I'm compensating by doing as many problems as possible. 1/8 of the outer diameter. What is the minimum required outer diameter D2 of the aluminum tube? Now it's aluminum. If its wall thickness is to be 1/8 of the outer diameter and the allowable bending stress of the aluminum is 50 megapascals. Okay, let's do it together. So again, I will go back. Everything is the same in this problem. Again, you can put a little green color here, and then you can pull it like this. Nice and beautiful. The only difference is this is hollow. So I will use the formula stress X equal to minus my over I with a Z here, or I can also use a beautiful formula M with a max, because now I'm using C, the max distance from the neutral axis. Okay, do it. You understand what you have to do, right? Oh, 1 minute. What you have to do? You have to plug in the M. Done. the maximum distance from the neutral axis. Now, it's a hollow structure, right? It's a hollow structure. But even for a hollow structure, your neutral axis goes through the centroid of the structure, although you don't have any fiber there. Although you don't have any fiber there, but even for this hollow fellow, the neutral axis in any case goes through right through the centroid. What you have to do is give me the moment of inertia. Huh? You have to give me the moment of inertia. So P is, what was P by the way? 12 multiplied by 1000 into 2.5. Multiply by C is d2 by 2, right? Divided by I is pi by, what was the formula? Pi by 64. Okay, pi by 64, but you have to be careful now. Good, good. So Google it. Google the moment of inertia of a hollow section and Google will tell you this. So it will be d2 power 4 minus d1 power 4. Now, what is d2? d2 is given to me as wall thickness. So I will say R2 minus R1 is equal to 1 over, no, this is confusing. This is so confusing. Like this, right? Huh? So R2 minus R1 is equal to 1 by 4 R2. Okay. Okay. So you have, okay. So you can just write it as D2 is equal to, I don't know. Just tell me what is D2?
0.3657.
The D2? You already found it? No. Oh, really? Okay. Probably is right. So you will say, okay, in the form of, I apologize. So your,
In the form of, what you want to just?
Oh, sorry, in a diameter, I want actually D1. So I think D1 will be 0.75 D2, right?
Yeah.
Okay. Not sure if everyone understood this.
Is this from the equation? No.
Yeah, this one, ne? R2 minus R1.
The other one.
So R2 will come here. So R2 minus 1 over 4 R2 is equal to R1. So D1 will come out to be 0.75 D2, right? You can play with it, right? Take this there, take R1 there, multiply the whole equation with a 2. So in this way, you will get 0.75 R2 is equal to R1 and multiply with a 2. So D1 equal to 0.75 D2. So last but not least, you will do number crunching. So here you will have 12,000 multiplied by 2.5 multiplied by D2 over 2 divided by pi by 64. Then you have, did you get the same thing by the way? Ahmed is your name, right?
Yes, I get.
You get the same thing. 0.75 D2 power 4 and 50 megapascals is the value for allowable maximum stress for aluminium. Nice and beautiful. Give me the D2. How much? You're not doing the problem. Give me the D2. Okay. All these are confusing steps. If you understand what you're doing, it's a game over. Stress is equal to m multiplied by the distance from the neutral axis. Stress is equal to m multiplied by distance from the neutral axis divided by the moment of inertia. Yes, no?
We use minus, but in sigma max we don't use.
I will tell you why. Look. I will tell you. I am using this because, first of all, it's pretty clear to me just by looking on which surface I will have tension and on which surface I will have compression. It's a circular object. On the chunk above the neutral axis, the whole semicircular chunk, there will be tensile, and because this is circle, right?
Yeah.
Below this line, I will have compression. So there I have tension, there I have compression. I can remove the negative sign, and just by looking at the drawing, I can make a guess. When I'm pulling like this, okay, this surface has tension and this surface has compression.
Does the negative sign change?
You can put the negative sign at the end that this surface has compression and that surface has tension.
So what is the final answer?
You give me the answer. 208 I have.
0.282.
Yeah.
208?
Yeah. No difference.
No, yes. Okay. Done?
Is it weird?
What?
But it's hollow.
No. This is aluminum. Okay. Oh, yes. Okay.
Aluminum,
Yeah, this is the allowable here is 50 megapascal. This is wood. These are different materials. So let me answer your question like this. But you cannot compare the. You can compare, but I will answer what you are thinking like this. So stress equal to my over I, and your textbook. Oh, okay. I apologize. Sorry. Max. No, you ask me what happened. I will answer this question. C is the maximum distance. Hence, I put the word max because C is the maximum distance. So max. And here I will put. Nothing. My over I. Okay. Now, what I am trying to say is I will answer your question like this. That what was that actually? My over I. Hang on. There is something called section modulus. So while solving questions, I don't write that like this, but since you have brought that up, there is something called section modulus. It is equal to M over stress, I suppose. If I can find it somewhere in the notes or book, so I can answer your question. Section modulus equal to M over sigma, let's say, and sigma max. So this chunk is actually, you can compare, this chunk is over M over sigma, I over C. I over C, right? You can please compare yourself. I over C equal to M over sigma. Okay. So this section modulus determines, this will also answer, determines how much material is spread away from the neutral axis. So I suppose a higher section modulus is beneficial, right? A higher section modulus is beneficial. No? How should I explain this? So for example, if you have in the last class, if you remember, we did a problem in which the beam was like this. And then we did a problem in which the same fellow was like this.
Yeah.
Do you remember? And let's say the load is applied like this. Which one is better?
The right one.
The right one, right?
Yeah.
Now the right one is better because the right one has a greater moment of inertia about the neutral axis, right? Because when it bends T, it becomes like this, right? So it has a greater moment of inertia about this. And this fellow has a lower moment of inertia. You are following, right, everyone? Because the class is so silent right now. So I suppose that everyone is understanding. So of course, right one is better. So higher section modulus is beneficial. Okay. I suppose that is pretty much the end of it. You can do one more problem. But before you do that, is there anyone who wants me to make X's and then do the left one, this one? So if you want to do with the X's, you can write stress X equal to minus. So clockwise, so it will be minus, this will be negative, right? Minus mz. So mz will be, this is, my thumb goes right into the whiteboard. So it will be minus 12,000 into 2.5. So minus 12,000 into 2.5 enters here. Okay, bracket. Then you have C. Now let's say I talk about C in the positive y direction. So I will substitute the value of, let's say D1 as 273 over 2000, right? Radius divided by the value of I, which is I Z, I suppose.
So this y is a scalar quantity. It means we are not going to take it as negative.
एक minute. Sorry.
This y, that is the distance from the neutral fiber, is a scalar quantity because you did not take it negative.
No. You're not getting my look. This is why. This is the value of y I substituted. What is the value I substituted? 273 positive. This means I'm talking about a fiber that is sitting here in the positive sense. You're not getting my point. This is your centroid. This is your coordinate system.
Yes.
Where is y positive? Towards the left, right?
Yes.
So follow me. This is y equal to 0. Y equal to 0.1 millimeter, 0.2 millimeter, 3, 5, 10 millimeter, and I arrive at 273 divided by 2. 273 millimeter divided by 2. So I'm talking about a fiber that is sitting here on this on this surface. Is it clear? Okay. So what is? Hang on, everyone. No, let me please finish. What is the answer? Positive or negative? Does it make sense or not? It does. It does, because when you are pulling it, this surface will be in tensile stress, right? So the answer has to be positive. But my point is, I will take your question after this. My point is, after doing all through this crazy negative and positive sign, I am coming with the same conclusion that this surface will be in tension and that surface will be in compression. Yes.
So in formula, the y means the fiber's position, right?
Nahin. Y means the distance from the neutral axis. Y equal to 0 means you are talking about the neutral fiber that is sitting right at the centroid. Y maximum means you are going maximum distance away from the neutral fiber.
So for example, when I don't know, for example, 140 divided by 2,000, for example, the y value. So it will go like this, but not maximum. So
Got it.
logically suggested.
Okay, good. I will answer your question. His question is, what is the meaning of y? When y is 0, you are talking about right at the centroid. The stress, bending stress at the center is 0 because the y distance from the neutral fiber is 0. Y at this point will have an intermediate value, somewhere between the maximum and the minimum. But y maximum distance from the neutral fiber will give you the maximum bending stress and subsequently the maximum strain.
So
Yes.
the left side of the cylinder will be in tension. Is that what you're trying to say?
Yeah,
Because the value is positive.
of course. When you are pulling it like this, of course, this surface is in tensile. Okay. Okay. Do we have any student who has any questions? Okay. I think we have to now proceed. So, okay. I will not do this problem, but I will make a comment. How would you do this problem? The same strategy, but right now I'm talking about the moment of inertia. Okay, what is the strategy? So the strategy is, let's say this is, oh no, but there is an easier way. No, I have an easier method. So for example, if all the dimensions are given to you, 3.25 inches, let's say 0.25 inches, you subtract actually both of them, okay? 0.25 inches, and you have 5 inches, again end to end, okay? End to end. 3.25 inches, end to end, okay? And again, this one is also 0.25 inches. So how, give me the value of I for this hollow structure. And I mean, let's say this is my neutral axis. So moment of inertia about the neutral axis. Let's say, let me finish the problem. This is a beam. And let's say I am putting the load somewhere in the center here. So let's say the value of moment I get is 50 Newton, 500 Newton multiplied by 5, let's say 2.5 kilo Newton meter is the moment. Generated, एक minute, it will become very confusing for you because you will be like, are you talking about force or not? So let's say this is, I want to start the next example by the way, but it's okay. Pardon. The force that I'm applying is 250 Newton. Okay, if it's a cantilever beam, then let me change the problem quickly. Otherwise, you will ask me, what is the length of this fellow is, let's say, 5 meters. Okay. Okay, let me finish it. Give me the stress X. I'm doing this because I wanted you to focus on moment of inertia. But then I thought that students will ask me to make a complete problem. And moment of inertia about neutral axis, of course. So you can determine, yes, please.
2 times 5 inch minus 0.25. No, 12.5 inch minus 0.25 inch.
No, moment of inertia. You are talking about moment of inertia. So for moment of inertia, find the moment of inertia of the big rectangle and then subtract the moment of inertia of the small rectangle. So please do it. Hang on. I put this in inches and I'm putting this in Newton. Oh, 1 minute. Let me copy paste the whole problem for you. Give me 1 second, everyone. Life is just bizarre right now. Bear with me. This is 100 into 10 power 3 pound inches. So, okay. Okay, force equal to, let me give you new values now. Force is equal to, let's say, 50 kilogram हो जाएगा 800. So let's say 80 pound force. The length is, let's say, 7 feet. So 84 inches. Okay.
Is it 12.97?
Okay, what?
Moment of inertia.
Very good. You did very quickly, by the way. So this is I about neutral axis is 12.97, right? Inch power 4. Okay, now if you want to see how this problem is, this is a cantilever beam, right?
How did you find the I don't understand.
Huh?
How did you find I?
Okay, I will explain. Did anyone else also get this answer or not?
Yes.
Okay. This is a cantilever beam. This is how I did. I did the moment of inertia of the big rectangle 3.25 multiplied by 5 power 3 divided by 12.
Yes.
Then I found the small rectangle 3.25 minus 0.5. This gives me this little length. Then I multiplied it with the height. For finding the height, I said 5 minus 0.5. It gives me this height. So BH cube by 12 again, and I subtracted. Give me the stress X, everyone. So it will be, this again goes through the centroid. When I bend, this will become like this. So hence you are of course you are finding the moment of inertia about the neutral axis. If this is your X, this is your Y, then your Z will be in that direction. So stress X is equal to the moment is in positive Z direction. Okay, positive Z direction. So minus
Will be
positive Z direction.
but the force goes like this.
No, moment.
Moment will be linked to C direction.
Minus. Huh? If I'm putting it like this,
Okay.
it will go about the Z. Huh? It will go about the Z. No, stand here. Stand here. You have an orange arrow here. The Z is in that direction.
Okay.
So
the moment will be.
This is the force. The orange arrow is the force.
Yeah.
This is
No. This is the force. This is the Z.
Yeah. So it's gonna bend like that, right? So it's
No. This is the cantilever. This thing will bend like this. Huh?
So it's in the negative direction.
1 minute. Okay. 1 minute. Load is here. This is bending like this. Where is my Z vector? Towards me.
Yes.
If the Z vector is towards me.
And using your right hand rule, it will be away from it.
Oh, okay. Okay, now I understand. Yes, he's right. I suppose. Yes. Yes. Oh, okay. I was the one who was making this mistake. Thank you. Good. Minus mzy. Good. Both of you. Everyone. Good. So it will be minus. You are so right. Good. Excellent remark by both the students. I was adamant actually, but then I realized. So it is 80 multiplied by distance is 84 inches. So multiply by the Y is the maximum distance from the neutral axis. So that is 2.5 inches divided by 12.97. Okay, so
do we need to put minus?
Yeah, inside the bracket.
Yes, because the moment in minus z direction.
Yes, Hushan.
The
Moment
minus.
is in negative.
Did we decide that the mz is negative, right?
Yes.
I again. So this comes out to be a positive answer, and the answer tells us that all of you were right. Very good. One problem over. Give me the answer. Say that again. 1290 kilopound per square inch. Okay, everyone. Again, this problem I created just to. I'm happy I did that, by the way. Good. Of course. Of course. Okay. So this is a negative sign. Thank you. Thank you so much, by the way. Excellent class, by the way, we have. mz is negative 80 into 84 pound inches. Okay. But we did not make such mistake before, right? Yes, I think we did not make this mistake before. Okay. Yes.
It will be PSI, I guess, because we use 0 force plus inch squared. So it will be not PSI.
No, I don't know. I don't have the calculator. Did you got the answer in kilos or? So it's in PSIs? Okay, you did not divide it by 1,000. Okay. Okay then.
Also, while calculating the I value, how can we decide which one and H which one?
Yeah, that's what I think we did last time. A couple of examples. You have to have the moment of inertia about the neutral axis. So for example, when this object, there's a force, the object will bend like this, right?
Yes.
So see this line. This line is about which axis? This axis. Which is this axis? The z axis. And that's why you see I have a z here. So your moment of inertia will be about the z axis. Had you put the force in this direction, how would your beam would have bent? It would have bent like this, right? Very good. Very good. So moment of inertia would have been in y direction.
So which one will be H and which one will be?
Oh, good, good. So for example, when this is the neutral axis, this is our B and this is our H. But when it was load was like this and it was bending like this will be your B and this will be your H. We did a couple of these problems last time. Okay, I think we can stop for 3 minutes now. So if we are doing more problems, for example, for B, this is in order to compensate for the homeworks. So for example, before the midterm, I will not be able to post excessive homeworks on this beam bending. But the number of problems and concepts we are covering, it should be sufficient for you to crack a problem on beam bending, okay? Okay. Break is over or? So
Are you making fun of us?
Okay, no. So what we can do is you can have a 3-minute break, and I can make a. You can have a 5-minute break, and I will make the drawing. Right? 5-minute break, I suppose. 5 minutes. 5 minutes. 5 minutes. What happened? What happened?
Help you to draw the
Okay, 5-minute break.
Sorry,
Why does it laughing, by the way? I did not understand. What happened?
In Metropolitan, we are at 10 minutes break. This is our right.
Really?
Yes. Always. You cannot,
guys, okay, 5 minutes.
you cannot arbitrarily tell us like 2 minutes or 3 minutes.
Oh,
That's why you're not.
Okay.
That's the reason.
If manager says 5 minutes, it is yani. What else can we
I
say?
think, okay, from next time we can have a 10-minute. I thought that 5 minutes was sufficient, no? So we can have a 10-minute.
Oh, but 5 minutes for
Okay, so next time onwards we will have 10-minute break.
as you wish. What else can I say?
Okay then. So I think dynamics exam was good. The difficulty level was decent. I suppose exams will be graded on Eid holidays because. Okay, let's actually change some topic. Okay, let me make some drawings because I think we have to speed up the process. So we have. So this is 10 millimeters now. So because I think enough problems have been done, we have to proceed in this topic. Otherwise, I will keep on covering the same structures over and over again. Okay, we have online students, Ehsan, Dogukan, and Abu with us today. Abu, do you have any questions?
I have a question, but it's kind of sort of unrelated to our topic.
Okay, what
Do
happened?
you know that when there is a flavor in the air?
Flavor?
Yeah, the one that is used to make bread. You know, flour.
Okay. The one we used to make bread,
Yeah.
flour. Okay, then.
So when it's mixed in air, because when you grind it, it becomes so fine particle. So when you throw it into the air, it mixes with air. So in that environment where there is very fine flour particles in the air, if you make an explosion, even the small one, it actually adds up and becomes a huge explosion.
I did not know that.
It's actually a real thing, and its power is really huge. Even a small explosion like a detonation of a bullet inside a pistol, which is control explosion, could lead to a massive blow up of the mines.
If you have flour mixed in the air?
Yeah, so I was wondering,
I don't know.
like from a physical perspective, Why could such things have happened?
This is actually the first time I have come across this, and it's fascinating to know. Probably you will have to Google some research that is happening. I did not know that, by the way. Wow. Is this a thing? I did not know that. Fascinating. So where did you come across this? Did you read somewhere?
I saw it in a movie and I thought whether it's real or not, because in the movies they manipulate physics on the.
Oh, okay. Then you may want to double check it.
No, I double checked it.
And oh, really? There used to be this program. I'm not sure you have heard of it. Mythbusters. Mythbusters, right? Few years back. MYTH. Mythbusters. Very good program. These were two engineers or scientists that used to, perform these experiments to double check. Whether the things that are going in the media, they are right or wrong. They used to crack myths.
So John, feeling better now?
Next time definitely we will have a 10 minutes break.
Is 5 minutes really enough for you?
No, actually, I was talking to him about some phenomena that he come across. Yeah, 150 mm, 120 mm. Okay, what is the question? So let us make a question out of it. I will also explain why this problem is so important. So we are definitely going. Okay, I'm trying to make a side view of this. I think I am successful, I suppose. Okay, the problem is that you have a pin here. And we have a roller here, I suppose. Okay. You have 4 kilonewton here. So you can note that I'm not getting into complicated bending moment problem right now, because I think you have gone through enough problems in your statics classes. Right? We are talking about some very easy 5 meters. Okay, the problem says that you have to find the neutral axis, that is y bar. Then give me moment of inertia with respect to neutral axis, right? Okay, this seems one tough problem, I suppose. The thickness is 15 millimeters. What happened? Okay. And then I have this fellow as 10 millimeter. Okay, do it. So how would you proceed? This is the first time we are doing such a problem. Number one, pick a reference line. Pick a reference line to calculate moment of inertia. 3, calculate I with respect to the neutral axis that we are doing. I. You are solving the problem, right? Yes, no. Look, what you have to understand is that the wood, for example, is very good in compression, right? Wood is not very good in tension. That's why you don't hang chandeliers with wooden sticks. We hang chandeliers with chains, right? Wood is not good in tension. Wood is good in compression. So if I have to use wood as a beam, for example, I do realize that wood is not the best choice for a tensile stress. So that's why when you put a beam that is wood, I do realize then when it bends, the surface below the neutral axis or the layers below the neutral axis will be subjected to tension, right? So I do have this thing in mind that wood is not good in tension. So I would love to have something like this. Are you getting my point? Now this object is made like this. So if you use this as a beam, what will happen? You have, by the way, this is not even symmetrical. How did I even make it? Let's shift this to the, oh, Jesus Christ. How would I do it now? Anyways. Okay, now I think it's symmetrical. So I would love to have greater mass on the lower section. And in this way, I am making sure then when you put the load, where would you put the load? You will put the load here, let's say. Here, right in the center. I'm making sure that there is this fellow sitting here, that when it is subjected to tensile, I have a fellow like this. So I'm happy. Is this part clear? And of course, I will have to shift this. Okay, now where does the neutral axis lie? It lies on the centroid. But the problem is that your centroidal line, you are not sure. Centroid for this structure does not lie here. Of course, it will lie a little below, right? Because of greater mass that is sitting here. So you have to pick a reference line. So let's pick a reference line together. So you can tell me, where should I pick the reference line? Okay, in my notes, I have put the reference line here. You can put the reference line on the top or anywhere you want. Then you find the centroid, because unlike your previous problems, you need to find the centroid now. So it will be I, AI, YI, then YI, AI, and then you can name them as, let's say, 1 and 2. So this fellow is your 1, let's suppose, and this fellow is nice and beautiful 2. So 1, 2, find this area, then find this area. So this is, I suppose, 1500 millimeter square.
No, first one will be.
No?
Correct.
1500 nahi? Yeah, 1500 nahi? Millimeter square.
120 millimeters. Which one is?
Oh, I suppose I have made some mistakes. Thanks for pointing out. Good. Okay, so the width was 120, I'm sorry. So this will be, what is YI now? Now YI, this is my section 1. So it will be 75 plus 15, 90, correct? So I found the centroid of this rectangle. Then I found the distance from my reference line. Okay. This one is 1800. 120 multiplied by 15. Double check on calculator. And then this one will be 7.5. Then YIAI will be 135,000 and 135,000, right? Then Y bar equal to summation YIAI over summation AI. So I will get nice and beautiful Y bar. You give me the value, I don't have them. Now that you have got your Y bar, you will calculate the moment of inertia.
This Y bar, is it the neutral axis or is it the centroid? Or is it, do they the same?
Oh, I think I said the wrong sentence. Now that we have the Y bar, we will calculate the moment of inertia. I think I ended up saying now we have the Y bar, we will calculate the neutral axis. I apologize. The Y bar is the centroidal line and neutral axis goes through the centroidal line. So we have calculated our neutral axis line. So I wanted to say first we will calculate the centroid. Then when we have calculated the centroid, the line that goes through the centroidal line, that is our neutral axis. We know it from the beginning. Now we will calculate the moment of inertia. Okay, I think I said the wrong English. So Y bar comes out to be 45 millimeters. So this is your blue line. So 45, this is 15. From here I will have to go 30. Yes, no. Okay, 30 millimeters. I will again emphasize, from the beginning I have said this, nothing has changed. The neutral axis goes through the centroidal line, for sure. For rectangle, your centroid used to be in the center. So our neutral axis used to be in the center. Okay. Okay, life is beautiful, I guess. Now we will calculate the I. Let me use.
So if we hold the plate on the vertical plate, if you hold the vertical plate and bandits. If you hold the vertical plate.
The vertical plate?
Yeah, bandits.
The whole, nahi. Oh, you, nahi. So the whole thing is bending.
Yeah, obviously, because it's a rigid body. When we hold the vertical plate, the bottom plate also is going to bend.
Yeah, the whole object will bend as one entity.
Yeah, so because of the bottom part, instead of the middle of the vertical plate, a little below the
Of course, because this whole object is one entity and the centroid that you are calculating is for this whole entity. And that's why the centroid has shifted a little here, because you have this big ginormous mass that is sitting here. If this was not here, your centroid of this rectangle was nice and clean here. So now calculate I equal to summation of neutral axis. What happened? So now you will create a nice and beautiful table, I1 and 2. Let me use different colors. This is your II. Then you have your DI. Then you have II plus AI DI square. Now you have to understand all of this you are doing. This is all very fancy if you do not understand what we have done till now. So the crux of the problem has been the meaning of neutral axis and those formulas. Yes.
For the Y part, you said 45 millimeters, but I calculate 81.81.
This one? This is the formula.
Y multiply by 8 and then add.
So you multiply this with this, you get this, then you summation, you add them. No, I have 45. Okay. No worries, no worries. So now I will use I as, okay, give me the I1, everyone. How will this structure bend? It will bend like this, right? So BH cube by 12. Now I am answering your question. So your question was which B, right? I am not even sure who asked this question. So since it is bending like this, this will be the B. So it will be B into H cube, because this rectangle is my 1 divided by 12. And the distance is how much? DI. So from the center of this rectangle, 75 millimeter, to the centroid of the structure. So this is 75 from the center. Okay, this is confusing. This is 75. No, from here it is 75. From here it is. One minute. 1 minute. This is 75 from here, and it is 120 from here. Okay. So 1 minute. This is my centroid. So it is 75 from here. So 120 minus 75 will give me 45. Okay, finally, after all this, I calculated 45. And this one will give me 585000. And I will finish the problem by writing 120 multiplied by 15 power 3 divided by 12. And this distance of the centroid of this rectangle number 2 from here is 30 plus 7.5, 37.5. And this will give me 256,500. And I will have I, for finding I, you will add them together. I, Z, which is I about neutral axis. You can use the word Z or NA. It is equal to the addition of both of them, which is equal to 8415,000. And last but not least, the formula is, I think we have students who are not following this. I will explain. Stress X equal to minus MZY over I. Now the moment we calculated, anyone? What was the moment? I forgot. 4, This is 4, this is 5. There will be a 2 here. There will be a, so 2 multiplied by 2.5 is 5. So minus. Now, again, the same, this is x-axis, right, along the fiber. This is my y. This is my z. So if it's bending like this, clockwise or anti-clockwise? So it is positive mz, I suppose. So I will put a positive mc, which is 5, as one of the students told me, 1000. Multiply by y divided by I. And let's say I'm asking you to give me the maximum tensile stress. And I will put the camera here. And I'm coming to your desk. You have to figure out now the why.
One thing I would like to ask, it was supposed to be compared on the base or on the top.
Oh, for sure. Recording is on, so everyone in the meeting can share the Suki share here and can share them with. Why Zoom is telling me this? After 3 years, Zoom is telling me. I don't know why. Your question is the load acting here?
Yes.
No, the load is acting on top of that film.
On the center.
The load is acting right up there on the top and that too at the center, otherwise torsion will happen.
Below that, right? It's acting on below that, right?
Load is acting like this. Okay. Load is acting up there on the top. Okay, give me the value of y. Anyone?
120. No. Minus 45.
So, give me the number.
You want the tensile stress?
No, give me the value of y. You gave me 120?
Minus 45 millimeters. So 0.045.
Oh, really? Okay. Good. Yes. I think you are right. Very good. You said minus 45?
Yeah, millimeters.
Very good. He is right. So multiply by 1 by 1000. Very good. How did he figure? I will tell you the answer. This is how he figured. This dark blue dot is the centroid, right? So your neutral axis goes through the centroidal line, right? So this is the fiber. Focus here. The fiber right above the. I'm sorry. The fiber 30 millimeters from here. This green one. So your neutral axis goes through the centroidal line. So if I am asking you to give me the maximum tensile stress, the maximum tensile stress will happen, or maximum stress for that matter will happen. The maximum distance from the neutral axis, right? So that's what we have to do. What is the maximum distance from here? When I'm talking about tensile stress, it is 45 millimeters from here, this surface, right? So, okay, 30 plus 15, 45. The I will be for the complete structure for sure. Even for this, you found the distance. So that is 8, 4, 1, 5, 0, 0, 0 into 10 power minus 3 4s are 12. 3 4s are 12. Okay. 10 power minus 12.
I have a question.
Please.
Since this shape is not a simple geometry, I argue that the connection point of these two rectangles is going to face with the highest stress. But in our calculations, when we are looking for the highest tensile stress, we took the maximum distance, which is not the connection point, but the bottom point.
No. Actually, this is not how it happens. So, for example, I understand your question that, for example, if these were two different fellows, we had welded them, for example. But when you many times join two different fellows, hypothetically, then many times it actually depends on the joining methodology. Many times the joint can become stronger than any other point. So when you're talking about the maximum stress, maximum tensile, it definitely, the bottom surface will be exhibiting the maximum tensile, hands down. There is no qualms to it. But you are actually, I know the problem. You are actually looking at this separate thing. That's why the confusion. It's me who is showing you as, in fact, if I show you a real beam.
I saw beam.
Of course. So do not think that for maximum stress, because right now we are talking about a maximum bending stress. Hands down, this surface will exhibit the maximum tensile, not the compressive. So you will not say that this surface will exhibit the maximum or endure the maximum stress for that matter. But your concern is that if it has to fail, it will fail from here?
Yeah, and I think it's because the maximum stress is going to be there.
No, maximum bending stress will not be here. I am telling you, look, there is another facet to this problem that we are not covering yet. Then probably what you are saying will come into the picture. That is the shear stress. So when it happens is we are going a little further. Look, when you are putting a load like this, right? This is a beam. I keep on telling you that you will have bending stress. That is fine. But the next topic will be shearing. What happens is when you are putting a load like this, then all these fibers also have shearing between them. Actually, there will be a lot of shearing between the layers. And we will see that actually the neutral axis line will have the maximum shearing stress. So when we incorporate that, then probably we will get more results out of this. But right now, as we speak, I'm specifically saying bending stress. So we will look from that perspective there, VQ over IV formulas.
Why are we 5 times 1,000? Why we said 5 times 1,000?
5 times 1,000.
Minus 5 times 1,000 for NZ.
Because I said, I'm skipping the statics part actually. This is 2 kilonewton. This is 2 kilonewton. This is 2.5 meter. I made a cut. I throw this chunk away. Then 2 multiplied by 2.5, I wrote the maximum moment that the object endures is right at the center. That's how I wrote 5 into 1,000.
How do we get that 37.5?
Okay, I will explain. So for finding the moment of inertia, I named this as section 1. I named this as section 2. For section 1, I did BH cube by 12 for this object alone. I used the distance DI from the centroid of this individual rectangle to the centroid of the complete structure. I wrote down that distance. For the second portion, this is BH cube by 12 for this fellow. 37.5 is the centroid of this rectangle distance to the centroid of the complete structure that I already calculated, 7.5 plus 30. Yes.
How we did the calculation IZ NA equals
yeah. So
million.
Yes. So I added both these chunks together and I got this. I added this chunk with this chunk, the moment of inertia of the first chunk with the second chunk. Okay, so give me the final answer of this fellow. So this is 26.7, megapascals. Okay, then the final bit is stress max compressive. It is equal to minus again 5,000 into y, all of you will tell me, and this fellow is again your IZ. We already know the value. I'm not going to put it here. Give me the final answer. The final answer comes out to be negative 71.3 megapascals. You have to give me the y.
Plus 120.
Very good. How did he figure? He figured like this. The distance from the centroid of the complete structure all the way up to this surface, because the farther you go, the more stress you will find. So all the way up to there is 120.
Isn't the unit should be gigapascal?
Really?
Because we have the 10 over minus 12.
10 power minus 3. And gigapascal is not physical. Gigapascal is not physical for stress. Megapascal seems correct. Okay. Here, are you sure? We really scaled up, right? From simple rectangles, we really made it complicated. So neutral axis goes through the centroidal line. I think we are clear on that. Okay. What is the value of stress? What is the value of the bending stress on the neutral axis?
0.
What is the value of the bending stress on the neutral axis? 0. Okay, I just think we are 12:03. I think we can do one more problem then. Okay, why don't you make that drawing?
Bending stress is also normal stress, right?
Bending stress is normal stress. Very good. Don't forget that. I keep on using the sigma, sigma, sigma over and over again. Remember that. The torsion that we talked about, that is shear stress. Okay, so on that note, why don't you all make this drawing for me, please? By the way, everyone understands the side view, right? You do understand why I made these two lines. I think you have gone through drawing classes. So from side, you will see these two lines, right? Okay. So why don't you give me this drawing? I'm coming to your desk. Make this drawing. Then I have, let me make this red line as my reference line for, and by the way, this is wrong. Yeah, sorry. Where is the neutral axis? Neutral axis is somewhere here. I was about to make a mistake. This was our neutral axis. So let me use a yellow line. Let me make a yellow line. Oh, what happened? Let me make a razor. Where is razor? Let me make a yellow line for. Okay, so. Okay, 71.3 megapascals. Correct. And what is your 26.7 pascals? Okay, then you make lots and lots of these lines. Okay, and what is the stress on the neutral axis? Bending stress? 0. And you have, again, I think last time we decided because when you're bending from this line, it will go away like this, right? Correct? Everyone can see this, right? Okay, Control Z. Yeah, Abdullah can also see this, so I can do a Control Z. You follow this one, right? This is how it's stresses that are behaving. Control Z. Okay. So then this one will be, you can do your whole own drawing now. Okay. Okay, so we know neutral axis passes through the centroidal line. Centroidal axis or centroidal line. And where is that one? The pink one. Okay. Okay. Okay, I think on that note, let's have a easy problem. The next one will take too much time. I think there's no point in confusing you. So I'm coming to your desks right now. I'm definitely not doing this problem, by the way. Yes, please, the question. Do this problem. Next time I will do one more problem for you. So the problem says that you have a pin joint now again. And this is again a nice and beautiful roller. Whatever. My point is this is a roller. The question says that, and unfortunately something happened. Okay, so unfortunately, I have it in British system of units, which is a little tough, but I think you will do fine in this example. So, this is Z. This is our Y. And our X will be correct. Okay. This is our 1.25 inches of height and 0.8 inches of width. I apologize, not 1.25 inches. I'm sorry. I think it is 2.5 inches. Sorry, 2.5 inches of height. Now the neutral axis will go through which line? Centroidal line, right? So this is your neutral axis. Nice and beautiful. You don't have to calculate the centroid. Find MZ that causes yielding. Sigma Y equal to 36 kilopound per square inch. And the object will bend in like right. Take a minute, 1 minute. Let me make the pin joint more carefully. I think now I have made it more carefully. So now it will bend like this. Good. Okay, and what is your Y? Your Y starts from here, from the neutral axis. Everyone is understanding, right? Why we are not calculating the centroid anymore? Okay, anything that I forgot? No. So do it. I'm not doing it. Even if I could not do this in class, I will post the solution. But definitely all of you are doing this problem today. Y, Z, X. Okay. Okay.
So does that say sigma y for stress?
Yielding, yeah, yield stress.
Not for like the axis y, just yielding stress.
It's a capital Y, not a small y. This is yielding. So let me use a little fancy Y here. Okay. I am coming to your desks. Let us ask our online students if they are doing it. Ehsan, Dogukan.
Allowable.
Maximum allowable unit.
In y here, so.
In my over I formula.
No, this is just y.
It's yielding. It's not
yielding.
It's not y. It's
yielding.
Yielding.
Okay.
It's not small y.
Is the answer 32 times each?
How much?
32 times each.
Good. You got it. Very good. Very nice. Okay. So he already did it. So let me. How would you make here? So for example, this will become like this, right? During bending. This means I neutral axis, that is IZ, BH cube by 12. No, 30. Answer. Oh, vertical distance. This is 2.5 inches. So the Y will be 1.25. So it will be stress X equal to minus MZY over IZ. This is 36 kilo pound per square inch equal to MZ is equal to negative stress X. Hang on with me, please. IZ divided by C, which is equal to negative 36 kilo pound per square inch. IZ is 1.042 inch power 4 divided by, what is the value of C? It is 1.25 inches. That is the maximum distance. So MZ comes out to be 30 kilo pound inches. And students who are saying, how did you find IZ, which is our I neutral axis? 0.8 times? 0.8 times 2.5 power 3 over, which gives you 1.042. 42 inch power 4. Boom. Okay. Did anyone do it apart from him before? Did you get the same answer? Okay, good, good. Few more comments, I think. So C is actually the maximum distance. And last time I remember, for example, for this problem, when I was writing the formula MC over I, then one of the students did stop me. He said, you are saying that C is the maximum distance from the neutral axis. So when you're talking about the tensile one, the distance is not the maximum from the neutral axis. So, okay, write the formula my over I and then substitute the value of y as minus 45 to get this 26.7. And when you're talking about compressive, this distance is definitely the maximum from the neutral. So you can just write MC over I if you want to be too meticulous. Okay. Any comments from me? I think we are done today at 12:18. Still have time.
If you don't mind, can you please explain me the sigma maximum tensile and sigma maximum compressive?
Yeah. So for example, if you're putting the load right from the top, the load is acting here, huh? Here. How this object will behave? The object will bend like this, right?
Yes.
Right? Okay. If the object will bend like this, then which is the fiber that will have zero stress? That will be the fiber that goes right through the neutral axis. That is the centroidal line. So your centroid is here. How do I figure? Because you can see, you see this blue color, this one, it is sitting right 30 millimeters from here. That's why I created this yellow line 30 millimeters from this. So this yellow fiber, this one, will have zero bending stress. So if you want to find the maximum compressive stress, if this object bends like this, so maximum compressive stress will be 120 millimeter from here, because 120 is the maximum distance from here. And maximum tensile stress will be 30 plus 15, 45 millimeter. So when I found maximum compressive stress, I substituted negative 45. And when I'm trying to find the maximum what did I say? When I want to find maximum tensile, I substituted negative 45. And when I'm trying to find maximum compressive, I substituted 120. For a rectangular section, it is not difficult. Rectangle is like this, right? So if the height is 20 millimeter, you go 10 above, 10 bottom, happy. If you're talking about a diameter of 20 millimeters, circular section, and I want to talk about maximum compressive or tensile stress, how do you figure? 20 millimeter is the dia. So 10, 10, 10, easy. This one is complicated because the structure is complicated. So the object will have a centroid which you have to find by hand.
And then how are we getting this moment at 5 times 1?
Yeah, because we are getting this moment because I skipped the statics part, so I will explain. We are getting the moment of 5,000 as I did RA plus RB equal to 4,000. Then I did minus R. I took this point and I took the summation of moments as 0, and then I found 2,000 here, reaction, and 2,000 here. Then I started making cuts. I made a cut right before this one, and it gave me minus 2,000 multiplied by 2.5 plus M equal to 0, and M came out to be 5,000. Are you getting my point? Huh. Time doesn't want to pass today. We still have 9 minutes. I think we can finish, or you have questions. Or we can finish the class and you have any questions you can ask me.
Yeah. Can I ask
Oh, huh?
Can I ask you one more question?
Yeah, why not? So that's pretty much it. I suppose. Do you want me to give you a homework question? Right? Right? Okay. Thank you then. That's the first time in my life we are leaving. Okay. Polar moment of inertia that you are taking. The polar moment of inertia you will take by having. Is this solid?
Yes.
So polar moment of inertia. Show me the polar moment of inertia. Power 4, 60 divided by 2. This is correct. Okay. Now show me T. This is 1.2723. Very good.
It's part A. It's the maximum shearing stress.
This is 15, not 30. Why are we substituting 30? Radius.
It's a bigger circle radius.
60 millimeter is the diameter of
It's radius.
Okay, maximum. Okay, sorry. What is your question?
What will be found the point stress?
What is the torque? Torque is I think so. Multiply by check the radius will be 50 into 10 power minus 3 divided by the same. So same thing. I only do dot d equals to 3 into 10 power 3 dot. Radius will be 50 divided by the same polar moment, because polar moment of inertia remains is for the same object. 1.2723. What is your question? What is the question? Oh, sorry.
This is not same here because he asked the first of torque why this is this portion.
Torque is the same. You think like this now, even in statics classes, when you used to cut and throw away, when we used to talk about moment, bending moment or moment, the moment remains the same on the same section. So torque is the same for the whole thing. Torque is the same. You imagine like this, no? You are putting torque on this one. So when you cut it, the whole thing is subjected to the same torque. The one section I'm talking about. So why is this confusing? Are you getting the same answer as the posted solutions or chat.com, let's say? Why are you confused on this one? This is so easy.
Kanka nasıl açıklayacağım onu açıklayamadım. Ben onu anladım.
What is the confuse?
Ne anlamadığını söyle.
Gel. Şimdi ben dedim ki buradaki torku ben eşit kabul ettim. Zaten eşitmiş ama şunu yapabilir miyim diye onu soracağım. Şimdi mesela içerideki dairede mesela birinin yarısı yani mesela biri 60 milim, biri 30 milim. Ben bunları oranladım. Normal maksimum shear stress'le içeridekinin yarı çapında dışarıdakinin yarı çapında oranladım. Evet.
Tamam. What is the question?
So
Hoca açtılar, ben açıklayamadım.
What is the question?
When making a ratio between the diameters,
because it's a hollow cube, right?
This is not hollow.
It's not hollow.
What is the question? One minute. Look, the question says the shearing stress at point D which lies on a 15 millimeter radius. So part B is done. Do you want me to tell you the part C?
Yes, sir.
Part B is done. Okay,
Okay.
part C. Part C says the percent of the torque carried by the portion of the cylinder within the 15 millimeter radius. Okay, this is the question. The percentage of the torque, okay, carried by the portion of cylinder within the 15 millimeter.
It will be one, I guess, because the torque is same.
No, torque acting is same, but
Kanka tork aynı ama bir küçüğün ne kadar yüzde kaç etkilediğini bulacağız. Nasıl tork? Ben de söyledim de.
Ben soruyu tam anlamadım aslında.
Bak ben sana soruyu anlatayım. Şimdi silindir var, tamam mı? Soruda silindirin içinde küçük bir şey varmış ama hollow değil. Yani küçük bir bölmeyi almış.
Büyük bir silindir, küçük bir silindir.
Aynen bak.
Ama onun
Büyük-
torku ayrı bulunması lazım.
Ya tork ayrı bulunmuyor aslında. Normal silindir var. Silindirin içinde küçük bir bölmeyi adam hani göstermiş sadece. Hollow değil. Çıkarmamış parçayı. Biri 30 milim içerideki, dışarıdaki de 60 milim. Tork uygulanıyor.
एक मिनट.
Genel tork.
Say,
Maksimum
read out this question. एक
Sonra
मिनट.
dedi ki, bu küçük silindirin dışında Z noktası var ya. Onun oradaki shear stresi bulunuyor.